So part two, what we're going to do is to swing the pendulum but over a small range. So here, this is for what's called a small angle approximation. And so here, we're going to keep the angle less than 20 degrees. And in this case, the pendulum is going to swing pretty regularly, and because of that, we'll be able to get a nice straight line. So in this case here, the angle is going to stay constant, and I believe the angle is going to stay at 20 degrees for this one. And so after that, and then you're going to repeat the experiment. Actually, no, let's keep it. It's going to be at 10 degrees. So the angle is going to be at 10 degrees. And so from there, the angle is going to remain constant. And now what you're going to do is you're going to vary the length of the pendulum. And again, you're going to measure the period, or the time to vibrate. So in this case, the experiment is going to look like this. So you're going to have a support system, and now what you're going to do is you're going to have a particular length, and you're going to swing the pendulum by 10 degrees, and again you're going to wait for it to vibrate 5 times, and you're going to measure the time for the pendulum to vibrate 5 times. And then after that, you're going to increase the pendulum's length to a new value. So let's just say that the first length here is, let's see, it's going to be, let's just say it's 0.3 meters. And then, for this case, and then you're going to increase the length of the pendulum to 0.4 meters. And again, you're going to repeat the experiment. You're going to let the pendulum, you're going to displace it by, again, 10 degrees. And from there, you're going to let it vibrate. So displace it by 10 degrees. And then from there, you're going to watch it vibrate 5 times. And measure the time for 5 cycles. And you're going to keep on doing that. So here, you'll get a table. And a table is going to have length versus the time to vibrate 5 times. So the length is going to be 0.3, 0.4, all the way down to, I guess, a set of values that you'll see in the instructions. And for each case, you're going to get the time to vibrate 5 times. But what we actually want is the period. So the period, remember from above, is going to equal the time to vibrate 5 times divided by 5. So the purpose of today's lab is to get that relationship. So really what you want is you're going to get the table, you're going to have, you're going to find the length, and you're going to find the period. And from there, you're going to make a plot. And in this case here, when the angle is small, all the sine terms that you see up here are going to disappear. And in this case, the theoretical period, so I'm going to call this T theoretical 2, that's just going to equal 2 pi, and then multiply by the square root of the length of the pendulum divided by g. So this is a simpler formula, and from this one, if you vary the length of the pendulum, you're going to be able to, and you in the period, then the only term that is missing is gravity here. So what we're going to do is we're going to vary the length, we're going to measure the period, and from that, you're actually going to be able to calculate the experimental value for gravity. So, in order to do that, we're going to have to linearize the data first. So in order to linearize the data, I'm going to rewrite this equation like this. So if you solve it, you're going to get the length of the pendulum is going to equal g, and then multiply by this term here, the period over 2 pi, and all of that squared. And when you do that, the equation is going to have the form y equals the slope m, and then multiplied by x. So what this tells you is that if you make a graph where the vertical axis is the length and the horizontal axis is this whole thing here, the period over 2 pi and all of that squared, if you plot that, then the slope is going to equal gravity. So that is how we're going to get the experimental value for gravity. For part 2, you're going to plot the length of the pendulum on the vertical axis and the period divided by 2 pi squared on the horizontal axis. And from there, then you'll be able to get the value for gravity as the slope. And that is going to complete most of the lab. The only other thing is to I'm going to give you the formula for the error analysis part, but that's actually going to be it for the data taking section here. So let's just review. So for part 1, all you're doing is that you're going to calculate the pendulum period versus angle, and you're going to compare it to this formula. And for part 2, you're going to keep the angle fixed, and you're going to change the length. And for each length, you're going to measure the time for the pendulum to vibrate once. And once you do that, you're going to make a table. So I'll put that here. You're going to make a table. And it's probably best that once you do your calculations in Excel, just put these numbers somewhere else in the file, on the spreadsheet, so that you can make a graph out of them. So you're going to put your period over 2 pi squared on one column, and you're going to put the length of the period in another column. Put them side by side, and when you do that, you'll be able to just highlight all the data at once and then create the graph. But the point here is that you're going to make a table of the period over 2 pi squared, and the length, and then from that you're going to plot on the vertical axis the length of the pendulum, and on the horizontal axis t over 2 pi squared. And once you do that, you should get a straight line, and a straight line is going to be the experimental value for gravity. So that's really what the data taking part of the lab looks like. The last part is to get the error for your calculation for gravity. So the error for gravity is going to be given by this formula. The error for gravity is going to equal your slope, or the experimental value for gravity, and then multiplied by the error in the length of the pendulum divided by the corresponding length, all of that squared, and then plus the error of the time, which in this case will be T5, because that's the one that you measure directly using a stopwatch, and then divided by T5 average, because actually you'll be taking several trials. And that's going to give you the error for your experimental value for gravity. And that is going to complete the lab part.